SMC provides latest automation technology, with more than 12,000 product series coming in more than 700,000 variations. Industry 4.0 and digitalization is a key factor for future business success, not only for SMC products, but in SMC Germany production site as well. SMC Germany factory is driven by cost level of lean production methods, but needs to meet full flexibility in product design and production for smallest lot sizes less than 10. Unquestionably, digitalization and cognitive technology meeting human-machine collaboration is promising to increase production efficiency in the future. SMC believes that the AUTOWARE project provides promising technologies for that. The human-robot collaborative workplace is equipped with the following components: assembly parts, manipulating robot, greasing station, clamping station, and scanning robot. The 3D scanner, developed by Fraunhofer IGD, has different components. A module for geometry acquisition supporting two different modules, precise acquisition and fast acquisition, and texture camera for 2D acquisition and visual inspection. The scanning robot acquires the three-dimensional shape of the physical parts. The side-by-side view shows how the point cloud is incrementally built.
The movements of the real robot are continuously mapped onto the virtual world, augmented virtuality. The point cloud generated by the scanning robot is transferred to the graphical user interface, GUI.
In order to identify the assembly state of the scanned part, the object recognition component automatically compares the point cloud with CAD modules available in company internal databases. Once the assembly state is identified, the next three assembly states are automatically derived from the semantic model and visualized on the right side of the GUI. After certain assembly steps, a visual inspection has to be performed, where clearance dimensions are visually checked. The generated point cloud is segmented by plane fittings which come from the corresponding CAD model. In this way, the correspondence between the CAD faces and the point cloud is established. It is important to note that the quality checkpoints are represented as product manufacturing information, PMI, within the original CAD models. This knowledge is automatically extracted from semantically rich CAD models and applied on scanned high-resolution point clouds. The implementation of our case heavily benefits from the AUTOWARE framework and solutions. Unquestionably, digitalization and cognitive technology meeting human-machine collaboration is promising to increase production efficiency in the future. SMC believes that the AUTOWARE project provides promising technologies for that. Enabling AUTOWARE technologies such as computer vision, computer graphics, and semantic technologies definitely brought us an important step further to our vision.